So welcome to the class. And as we have another presentation today after a couple of weeks breaks. Thank you very much all for the attendance and the facilitators, the organizers, the coordinators behind the scene. You all appreciated. Wishing everybody, the participant, and all the best in various careers. So today we are going to be looking into application of machine learning in crop production. I said it's revisited with practical demonstrations in Weka. We had almost 3 weeks of the discussions on application of machine learning in crop production earlier on, several weeks ago. So, and I've posted the link. We can see the link in our YouTube. The videos are there. We have part 1, part 2, part 3, with each part having question and answer, making 6 videos altogether. Part 1 questions and answer, part 2 questions and answer, up to part 3. So I earlier shared the link to those videos in this Zoom chat. For the sake of those that just joined after I shared it, any participant can just volunteer to copy and paste again for the new participant who just joined after I pasted the link to also benefit. And all this video we can see in our archive on the YouTube channel. So we welcome also those. We know there are several hundreds of our members that just joined. And since they joined, this is the first time we are having a lecture. So we welcome you all. Presently, I think the WhatsApp group has already surpassed 8,000 participants. And that is a big jump from the previous time we met. However, I welcome you all, and I want to assure you that even though you are just joining, you can easily call. It's a lecture, it's a machine learning for all. It's made in such a way that we can easily understand whatever we've discussed in the past. Just follow instruction. Make sure you join the WhatsApp group, subscribe to our channel, YouTube channel, so that when we post a video, you can easily check it out and get an advantage from that. And also, from time to time, there are like 4 videos. We call it general summarized introduction to machine learning. After that, we had another 3, call it building your first model in Weka. Another 3 videos that demonstrated how you can start building your own model using Weka platform. So those 7 videos, they are often repeatedly posted once in a while on the WhatsApp group. We strongly encourage the new members to watch those videos. They are made very simple to understand, and then also try to practicalize it. Weka is a free software. Download it on your computer and start exploring. So again, you're all welcome. There's nothing to fear. Even though you just join us, you are as good and ready to go if you follow those instructions and also continue to pay attention to other engagement we're going to be having. And you're always welcome to communicate privately, seek clarifications as the case may be. The essence is to try as much as possible to bring as much as possible people on board to be able to know how to use AI and machine learning and the related technology towards advancing our various careers and benefiting ourselves and humanity in general. And we will have the opportunity to do so. Now, today we are going to move into the presentation proper, that's the application of machine learning in crop production, revisited with practical demonstrations in Weka. As you know, agriculture is an age-long means of livelihood of millions or billions, through which several people are fed globally on a daily basis. We cannot do without agriculture, and that was the passion that made us add series of videos in the past, and we are back to it again, especially to see how practically can we actually utilize machine learning towards increasing food production, avoiding disaster in the agricultural sector in a timely manner, taking the decisive decision that can ensure that the world is safe from famine by the mercy of God, Almighty God himself. The global demand on agricultural products, as we all know, continue to increase over the years as the population soar, as people are having more comfortable life. They want to have different type of foods at the same time, putting more pressure on the farmers towards ensuring the smooth flow of the supply chain when it comes to agricultural products. By far, the most important products in the world. If you can't afford to change your shoe, you can continue to manage the one you have. You may not be able to change your clothing. You may continue to manage the one you have. But when it comes to food, you cannot continue to manage the one you have because it will finish. It's something that we consume. We have to keep replenishing it, replacing it. And that means there is need for us to pay more attention to how can we support this system towards making sustainable agricultural produce generation. Given technological advancement in farming, machine learning, and AI method can be leveraged to increase efficiency and accuracy in decision making, while also reducing risk and costs associated with agricultural operations. I said then that a case of predictive machine learning solution, we're making case for predictive ML, or what we call predictive analytics. Of course, we can also use descriptive analytics or diagnostic analytics. But let's see, how can we use predictive analytics? Other time, we can have the opportunity to also expatiate on the other types of analytics as it relates to agricultural produce. So when we made case for predictive solution for crop production using machine learning and AI, which involve leveraging data-driven insight to optimize farming practices. So if we have an idea of what we may produce, if we do this, then we can be able to change the parameters. Maybe the planting time, is it going to be rainy, the pest control. As you know, agriculture faces challenges such as unpredictable weather conditions. Witnessed last year, people planted a lot of things and rain did not come. And did not make provision for irrigation. That is a big issue, unpredictable weather condition. So can we have an idea when likely there's going to be rain this year? This is becoming possible. It's possible with the use of effective predictive analytics. Pest outbreaks, can we have an idea of when the pest is likely going to come up so that we can put in place what we call proactive management? We don't wait for the problem to start, then we start solving them, but we have an idea that this thing may start next week. It is not magic. It is a science. And that's why we call it data science. With the availability of huge data sets, we can actually make use of AI and machine learning towards ensuring that we have an insight into what may possibly happen, following what happened in the past, considering the type of data that we're having at present. So we build model using past data, and that past data model can now be used to extrapolate towards future, all things being equal. Therefore, the need for efficient resource management is very highly needed. If we know that this will happen, we can afford to do this, we can suspend this. So a predictive solution for crop production using machine learning aims to address these challenges by analyzing historical and real-time data, thereby making it possible for us to make an informed decision about planting, irrigation, pest control, harvesting, and also for other activities that are associated with crop production. If we take a decision to start harvesting 2-3 days before, perhaps they could have saved us some possible pests that could have destroyed the system. These are all made possible with the availability of data. However, are we making use of the data that we have at hand? Definitely not yet. And this is why this kind of presentation is necessary to sensitize us. Luckily for us now, we've started having a lot of people who are into agricultural practices who are already also joining our team. We are professors, we are practitioners, students, both undergraduates and postgraduates who are very much interested in the agriculture. And every one of us has to be interested in agriculture because we eat. Even the speaker himself now, I'm very much interested in it. So, because if we can ensure food production, hopefully challenges here and there is one of the major challenges of humanity. Food is very important. Why there's wastage somewhere else, some people are suffering from famine somewhere else. What can we do? Can we use effective data analytics to be able to ensure effective distribution of food, to avoid wastage in some areas while making sure there's no famine in other places? So predictive solution for crop production, these are possible components like data collection, machine learning models, IoT sensors, remote sensing could be used, decision support system. This is very, very important, where we can integrate a lot of predictive models and sensor data into decision support system that provide actionable insight for farmers. So farmer will have a lot of information at his disposal of what may possibly go wrong. I call it preemptive monitoring of agricultural production system. So with effective deployment of this, we hope to have a lot of positive expected results, like farmers who then experience significant increase in crop yield due to more informed decision making, resource utilization effectively, including water and pesticide. This could be well optimized, resulting in cost saving and environmental benefit. Sometimes we have a lot of age-long practices that are no more necessary. With data, we can be able to detect and appreciate this. I give an example. You see, in oil production, in oil drilling production, they have to monitor some parameters to be able to ensure that the drilling is going properly well. Experts have been using like 3 parameters that must be monitored out of several other parameters. They have to monitor these 3 continuously online, people 24/7. Some people will not sleep, they have to have shifts. However, when they brought in data science, data mining, they were able to identify that instead of monitoring 3 parameters, there is one from this present 3 and one that has been dropped, considered to be not very important by experts. It was detected that if you bring in one from the present 3 that are being used, plus one that has been discarded, these only 2 newly detected parameters are enough to effectively monitor the drilling operation better than what they were doing before. That is the power of data mining, data analytics. See, as an example. So some of what we were doing before, even in crop production, in the agricultural practices, some of them, because things are changing, there are a lot of different types of crops, genetically modified, a lot of hybridization to improve yields and the likes. So what crops were responding to before in the past, they may not be responding to it. However, it takes time before people realize it. Well, with data analytics that could be effectively utilized, we can have an idea of what may go wrong and we can prevent it. So in what I call proactive or preemptive monitoring system for crop production. So we could have, this will result in cost savings and environmental benefits. Early detection of pest outbreaks allow for targeted and timely interventions, thereby minimizing crop losses. Imagine you have a predictive solution that identifies that there will be pest outbreaks so week of the month, or few days to come. Because technology has made this very possible. Because when this pest outbreak happened last year, 2-3 years ago, we have the data. Machine learning is able to sift through the data and determine what are the characteristics that once it is present in the atmosphere, once the weather conditions support those pests, the same outbreak that happened like 10 years ago may happen again. If we have this kind of data analytics solution, we can quickly predict and tell the farmers there will be pest outbreak so weeks. Please be on the lookout. Start spreading some of those preventive chemicals that can prevent them from actually coming up. It's better than, as we know, prevention is always better than cure. So that is on some of the expected results. improve sustainability practices and reduce environmental impact through precise resource management. So having effective predictive solution in a preemptive manner will go a long way to ensure our resources, which is of course very scarce and not always enough, are effectively and precisely managed. Now, so moving further now, we are going to look into one of the practical demonstration of how we can do this. Let's say we want to have an idea of yields. And I want to encourage us, go online, look for, when you are starting, we've discussed in our previous videos, how can you start it? Let's go, you can look for data. In addition to the data you are having yourself, then you can also look for data online to see what is the data. Somebody asked me, said, sir, how will I know the kind of data I need? I said, yes. If you have experts, sit down with experts. But the better way to do it, very good way to do it, is to look for data online. Look for online data set. Go to websites like Kaggle, UCI repository, and so many other data sites that we've shared in our forum, and we keep sharing more, inshallah. So check them out, see what information they gather that made it possible for them to do the prediction. And from there, you can also have your own system that you can build for the predictive solution. Now we're going to have a simple data set that we are going to look at it together. This data is about trying to predict yield. We want to have an idea of the yield production that we can generate from a particular farming system. So let's look at this. The first thing is we are all encouraged to install this software, Weka. You can see it here. Let us install Weka. So I can enlarge it to make it easy for you to see. Yeah, so if you install the Weka, you go to Explorer. You click Explorer. So this is where we want to work. Click Explorer. Once you click the Explorer, you have it open. You have some other things. When you watch the first three videos on practical demonstration in Weka, which we usually forward to the WhatsApp group, you will see how to download Weka, how it works. What,
yes. Sorry, I can't see the Weka. I'm not too sure if the polling is my side. You can't see the Weka.
Okay, you can see the Weka. Okay, let me see. Can you see it now?
Yes, yes, yes.
Okay, thank you very much for letting me know that. So when you go to Weka, you start it, you can click Explorer. We have experimental, we had it discussed earlier, so we don't go into that. We need the Explorer, click it. And don't forget, you can always go to the tool. You have the tool package manager, whereby if there's any software package that are newly developed, they are not yet in the one you installed, just go to package manager and you can install them from the package manager. You can always add what is not available. So click the Explorer, and then you click the Explorer, you can open it. Yeah, the Explorer is out here. I hope to believe. Can we see the Explorer? Hope you can see it, Doctor.
Yes, Prof. You can see, but it's overlapping with the main presentation.
That's fine. We don't need the other one.
Okay.
Well, yeah, we can always go back there. Yeah. So in here, you open the data set you want to use. Open. You must have prepared your data in a CSV file, which is just like Excel. It's the easiest way for you to prepare your data. If you are using Excel, that's fine. Put your data in Excel and then save as CSV. The difference is you make sure it's only one sheet in that file, and you save as, and then that make it to be a CSV. Weka can accept it easily. So, like I said, you can watch the earlier video on how you can install Weka. It's free software. So click open file. You can see before you open the file, everything is gray out. It's gray out. So I click open file. I try to locate where I have my data, because by default, Weka is looking for .arff file. So it cannot see any file there. So I have to manually select that. Look, I'm looking for file type of CSV. CSV. Then it will bring it out for me. You can see I have the file store here. It is crop yield predictive file. So I click the file and I can open it. Once you open the file, now this data is loaded for you to be used. So you have a small data set with 6 variables. One of the variables is the output, which is the yield. The amount of yield, we all know what is yield, what you can possibly produce in this situation. This is the crop type. This is one of the variables. Given these crop types, cocoa beans, then oil, palm fruit, rice, paddy, rubber, natural. There are different type of crop that you have the data. Precipitation, we all know that precipitation. So what is the value of precipitation? It's numeric value. You can see here, you see the minimum, maximum, mean, standard deviation. These are the characteristics of the attributes. We have the specific humidity. So at 2 meters, gram per kg, then you have the relative humidity, then you have temperature. So what we are trying to see is, if we have this type of crop at these conditions, what is the expected yield that we can look up to? This is a very simple data. It could be data for any other agricultural produce related. But let's look at this as an example. So the target is yield. This is what we want to predict. And usually, it's good to let the target be on the rightmost part of your Excel file. When you are building your file, your data, the rightmost part should contain the target. Of course, it can be any part, but you have to set it manually to indicate which one should be the target. If you forget, it means you'll be predicting wrong information. So I usually encourage people to make sure the rightmost part of your file, of your Excel file, contain the target variable to be predicted. Now, let's look at it. Once we have loaded it file successfully, we go to classify. They were gray out before. Now we can classify, we can predict because of successfully loaded data. Now we go to it, we can choose from the available. The next is to choose how do you want to break your data. Do you want to use cross validation? Or I want to use percentage split. Let me use percentage split. I want to use 70% for splitting, 70% for training, and 30% for testing. So then, and you can have cross validation. We discussed all this type earlier. We can watch some of the videos on how to build models. Once we set the target, we set the parameter for the partitioning, 70% training. The next thing is for you, there's a default algorithm that is actually there, 0R. However, let us choose the one we've discussed several times, which is very easier to understand. We call it the IBK, or K nearest neighbor. When you over it, you see different, the description is there. This is K nearest neighbor, which can select appropriate value of K based on cross validation, this and that. You want to know what they're all about. So let's go for IBK, which is called K nearest neighbor. It's an algorithm that is based on the principle of show me your friend. I'll tell you the kind of person you are. If I know if you have 5 friends, 3 of them are good, 2 of them are bad, then you are likely going to be a good guy based on the voting, 3 against 2. So this is a very simple algorithm in machine learning that has proven to be very powerful on several fronts. So we're going to demonstrate it and see it can work on both classification and prediction solution. This is something that is unique about Weka. About K nearest neighbor. It works for both classification and regression. Where we have some algorithms that can only work for classification, but not for regression, while others can work for regression, but not classification. But in this case, it can do both classification and regression. Assuming that you've watched the introductory video, regression is when you want to predict numerical values. like yield. You want to predict the age of someone. These are referred to as regression problem. But when we have to do classification, when we have to do classification problem, that is when you want to predict if this is yellow or red, if this thing is good or bad, if this crop is going to be bad or good, if there's going to be pest or no pest, yes or no, or multi-classes. We call them classification problem. So the K-nearest neighbor had the capability to work on both classification problem and regression. But for this example we are using, it is using it's a regression problem because we want to predict yield of crop. So now we've successfully selected K-nearest neighbor. So if you click here, you can let us run our first experiment quickly. So you can see here, it automatically pick yield as this is the one you want to predict. The one in the last column is automatically selected. But if you know what is in your last column, it's not what you want to predict, then you have to change it here. Select, maybe I want to predict precipitation or specific humidity. You have to select it manually. Otherwise, it automatically selects the last column of your data file. Once you are done, you are ready to go. We can click start. And then the data is not very much, so it's done. So it has successfully predicted the value of yield for the testing set. This is the testing result. We may want to show you further. You can see here correlation coefficient is 0.99. It means the predicted values and the original value, they are correlated to a degree of 99. It means as one is increasing, the other one is also increasing. Root mean square error, though still very mean absolute error, these are the errors. Root mean square error, these are still the error. And this is why it's always good to have more than one performance measure when you are measuring the performance of your model. You see, you can see that even though correlation coefficient says it is 0.99, is 99.64, you can see the error is still higher because these are big values. You see? So you have to move further to see, okay, and this is just for, if you click here, we can do hyperparameter optimization, KNN. The number of K is 1. If I increase K to 2 or 3 or 4 or more, what do I get? Because this is called hyperparameter optimization. As you change the value of K, the performance may be increasing. You run it again. You can see the performance has increased from 0.996 to 0.997. So I can keep increasing K. Maybe I make it to be 7. You are looking for the K that will perform better for you. It goes back. It went back to 996 now. So it means it's getting bad. So I go to 5. K is equal to 5. You play with the value of K as much as possible. So it's 996. It seems we are getting the best value at 3. We are getting the best value at 3. So 9974. So at this point, it's very high. It's a very good performance. So this is a model. Then you take out this. What you can do for that to really appreciate what you have done is try to see what is the actual prediction. Where are the values? Then you can go in here. You can see, I want to see my output predictions. I want to do the actual prediction. It's null. Null means don't show me. I don't need it. You now choose, how do you want to see it? I want it to be written to another CSV file. You choose CSV file. You want it to be in HTML? Let's choose plain text. Plain text means it's going to show it on the same window we are running our program. So we have chosen plain text. Okay, now run the model again. You can see here it's showing us the actual prediction. This is for training, for testing set, the 30%. This is the 30% of the data. The 70% has been used for training and left. Now it's using the testing set, which is 30% of the data for testing. And this is the result. You can see now that for the first instance data, this is the actual value, 151,070 is the yield for that plant for that particular crop. And our system predicted 159,570. The error is 8,000 plus. When you are talking of hundreds of thousands, 8,000 is a very reasonable error for a system that is just starting. And we're using KNRS neighbor, which is one of the very simple systems. If we deploy more sophisticated system, hopefully we can bring down the error. Then you see the next instance. This is the actual value, 5,900. It predicted 6,180, which is very close. The error here is 277. That is, the farmer can have an idea of, if you do this in this particular condition, this is what we are expected to get. So machine learning is saying you are going to get 6,180 yield. Meanwhile, the actual is 5,000. There's a little error plus or minus. You see some are minus error, some are plus error. This is the idea we are talking about, that we can use machine learning to make predictive solutions that will assist our farmers to be able to have an idea of what they are expecting so that they can up their scale. Maybe this yield for the particular crop is not going to be good. Then we can go for those crops that are going to have better yield and focus on them rather than planting those that will not produce more yields, or as the case may be. Of course, we know that there are other parameters that are supposed to be considered, but this data does not have them. However, it is a good place to start having an idea of what do we say or what do we mean when we talk of using machine learning as predictive for predicting crop production or yields, as the case may be. So, and I'd like to show you the file. This is the file. This is the actual file. You can see the file. This is the file we're using for the prediction. You have crop, you have precipitation, we have specific humidity, we have relative humidity, we have temperature. The more the number of variables you have, the better, because we can talk about how to do feature selection later on. How can we improve this result for that? So because of our time, I believe the data set is made up of 157. So we divided into two, the training set and testing set. So I believe it's a good place to stop for the day. We give room for possible questions and answer time if there is. And then hopefully another time we continue to expatiate more on how can we use and improve upon the result we've gotten. Thank you very much for listening. So now we are going to give room for question and answer. Thank you very much. And I wish you all the best.